Okay, so we're given a region bounded by y equals 0, a bunch of other stuff. We're supposed to compute the center of mass. So I have all the necessary formulas from the text for that. So we got a graph cosine of 2x. Cosine, when it's not altered much, like when we're not multiplying by negative on the outside, and we're not adding or subtracting to make a vertical shift, it starts at the peak of the amplitude. And it's cosine of 2x. So the period, which means the amount of time until the sinusoidal wave repeats itself, is 2 pi divided by b. And b in this case is 2. So this cosine wave should repeat itself by the time we get to pi, which means it needs to go down to the bottom, then back up, and that's where it's going to start repeating itself. And then same thing going backwards, negative pi, it should be repeating itself. It should be back to the peak of the amplitude. So that's a really rough sketch of cosine. It needs to be between y equals 0, so the x-axis, x equals negative pi over 4, and x equals pi over 4. So it looks like it's this region in here. And you can check to make sure that pi over 4 is where it intersects. If you plug pi over 4 in for x, 2 times pi over 4 is pi over 2. Cosine pi over 2 is 0. So we need this region. What are we going to do? We might have to split the integral in half and then double it because it's symmetric on both sides. I can't, well, the limits of integration are going to be pi over 4. I guess I got to do the antiderivative first. We'll take that one step at a time. So the center of mass is this. We need to know the moments with respect to the x and the y-axis. So to find those moments, we're going to integrate from negative pi over 4 to pi over 4 of f of x squared, so cosine squared 2x over 2. And then we need to integrate from negative pi over 4 to pi over 4 x times cosine 2x. Often with trig antiderivatives, we need to rewrite them using some sort of trig identity. So this one over here is going to lend itself to the power reduction identity. I guess that's one way to call it. It's also called the half angle formulas, I guess. So we're going to factor out that 1/2. And then I haven't done any calculus yet. It's negative pi over 4, pi over 4. I'm going to make that be 1, actually let's do 1/2, 1 plus cosine 4x. The reason I can do that is because if you have something being squared, then you can double the argument. So theta in this case is 2x. Double theta is 4x. And then instead of dividing everything by 2, I'm just multiplying everything by 1/2. That way I can factor out another constant. And then we've got 1 plus cosine 4x. So that's going to be x, evaluated from negative pi over 4 to pi over 4, plus antiderivative of cosine is sine, because the derivative of sine is cosine, but we need a 1/4. That way, when you take the derivative, you have something to cancel out the 4 that results from the chain rule. Okay, so if we plug in our limits of integration, this is pi over 4 minus of negative pi over 4, so this is pi over 2, because that's pi over 4 plus pi over 4. And then here, sine 4 times pi over 4, that's sine of pi, which is 0. And then same thing if you plug in negative pi over 4, you're going to get sine of negative pi, which is also 0. So we got pi over 8. So this is pi over 8. So to find this. This one actually, I don't see any of these helping because that's going to make it squared. That won't lend itself to u substitution. So we could do, let's get rid of this. We could integrate by parts. In integration by parts, you choose a u and a dv to substitute the whole thing. So I'll let u be x. That way du would be just dx. The power reduces. We have something less complicated to work with. That means dv is going to be cosine of 2x. So v, the antiderivative, is going to be sine, but with a 1/2 out front. That way, if you take the derivative of this, it turns back into this. Okay, so we're using the integration by parts formula. It's u times v, so it's x over 2 sine 2x, minus the integral of v du, which is just dx, sorry, which is what we want. It's an integral with respect to x. So you can factor out that 1/2, and then the antiderivative of sine is negative cosine. So I'll take the negative sign out front because it was negative cosine. Now, and we need an extra 1/2 because you want to be able to take a derivative of your antiderivative and get back to where you started. Derivative of cosine is negative sine, so negative negative would make a positive sign. So that's why we need that negative on the outside. But we also need an additional 1/2 because when we take a derivative of this, a 2 is going to come out. So we're going to multiply the 1/2 to the 1/2 that's already on the outside. And then we evaluate that from negative pi over 4 to pi over 4. So we got x over 2 sine 2x plus 1/4, and then pi over 4 in here, that gets cosine pi over 2, which is 0, minus cosine negative pi over 2, which is 0. Oh, and I forgot to evaluate this one. That was part of our antiderivative. We got to evaluate that from negative pi over 4 to pi over 4. Okay, so if I plug in pi over 4 divided by 2, that's pi over 8. And then sine pi over 2 is 1. And then plug in negative pi over 4, you're going to get negative pi over 8. And then sine of negative pi over 2 is negative 1. Negative times a negative makes a positive, times another negative makes a negative. I get 0 over here. Last thing we need is the mass. So we're going to integrate from negative pi over 4 to pi over 4 of cosine of 2x. Integrate from negative pi over 4 to pi over 4 of cosine 2x. So the antiderivative of cosine is sine, because the derivative of sine is cosine. But we need a 1/2 because when we take the derivative, the chain rule is going to produce a 2 as a coefficient. So that's our antiderivative. And then if we evaluate that from pi over 4 to negative pi over 4, sine of pi over 4, sine of 2 times pi over 4, that's pi over 2. So sine of pi over 2 is 1. We're going to subtract that by what happens when we plug in negative pi over 4. So 2 times negative pi over 4 is negative pi over 4, negative pi over 2. Sine of negative pi over 2 is negative 1. So this is 2. 2 times 1/2 is 1. And now we're finally ready to answer the question. This is 1. And the moment with respect to y was 0. And then this one was pi over 8. So we got center mass for the x bar is 0. And for y bar, it's pi over 8.